So this one is problem C, and this is also volume by rotation. And this one has set up a little bit differently. It's the same curve, and it tells me that is the region bounded by the horizontal line y equals 9. Okay, now this is a little bit different. There's y equals 9. And so it's this line and the line x equals 6. And so this is x equals 6. So in the curve, in the first quadrant. So this is actually our region that's being rotated. And it tells me that we are going to rotate it around the line x equals 6. So that makes this our axis of rotation. And that's a little bit differently, so that things are going to go this direction. It's going to go around in this direction. And so this little piece here is going to actually end up getting rotated around and come this way. And so it's going to go here. And this is going to make like a little funnel shape. But notice this shaded region is all, there's no airspace, I like to call it. It's really tight right up next to this axis of rotation. So it is still a washer. It's just going to make things a bit more complicated because it's not actually here against our axis or down here against this axis. It's in the kind of in the middle. So we're going to do the same process. We are going to do volume equals pi from A to B. And I need to know, see my circles being sliced this way? So my circles are being sliced in the dy direction. And I still need my radius squared. Now, in this case, my radius is going to be in terms of y, because I'm slicing things this way, or I'm rotating up and down according, like it would match the y-axis. So the way to do that is I'm going to back up and I'm just going to look at this one little pink line right in here. This is my little slice that I want to pay attention to for the radius. I know it gets revolved, I know it gets over to the other side, but this is my radius. So my radius is going to be right minus left. So my right is 6 minus, this is 6, this curve. And so I'm going to put for a moment curve. It's not very mathematical, but I want to come back and figure it out. This curve is this function. This function. If I use it in this y form, I'd put x's right here. That'd be 6 minus x, blah, 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 blah. That won't help because I need to be in y's. So for my previous video, I solved for y and I made this same function, I just put it in terms of x. So what that's going to mean is my radius is going to be 6 minus, and I have to use this other form because it's going to be negative 4y plus 36. No, do not distribute that in. That's going to make it a mess. So this, now notice I have everything, and the only variable in here is y, so I can plug it right in. So I'm going to put 6 minus the square root of negative 4y plus 36. Again, I do see that negative. Doesn't much matter to me right now. And then the rest of it is going to be dy. And I'm going to integrate with, don't forget my pi. And I'm slicing this way, so I'm going to go from 0 to 9. 0 to 9. The math, the algebra with this gets a bit messy. I'm not here to do the math with this. I'm here to make sure we can do the calculus, and that's this setup. So the answer, you can even type it in your calculator and check it out, is 53.999 repeating pi, or approximately 169.646. And if I had some units, this is volume, so it'd be units cubed. I don't have any units, so I just leave it alone. Hopefully that's beginning to make some sense, but this is still a washer because it's snug up against that axis of rotation.